All right, so let's go ahead and look at some non-unit circle examples. All right, now for non-unit circle examples, really quick, we do have some formulas per se to help us find the other angle since the calculator, these are going to be calculator problems, the calculator will only give us one angle. So when we're working with cosine or secant, right, cosine and secant are just reciprocals of one another. In order to find the other angle, we're just going to take our angle that we do find and subtract it from 2 pi. For sine and cosecant, we're going to take the angle that we find and we're going to subtract it from pi. And when we want the other angle for tangent and cotangent, same thing, pi minus theta. Or we can just add k pi since the period of the period of tangent and cotangent is pi. Right, and this is all just derived from the placement of these particular functions or the values of these functions on the unit circle or on a circle, okay, non-unit circle. So I'll go ahead and show you how to apply these when it comes to solving equations that are not coming from the unit circle like they were in the previous one. Okay, so let's go ahead and look at an example. Example. Let's say we have 5 times, that's an ugly s, secant squared 3x. So this is just secant of 3x squared. It's like having an x squared, but it's just notation. Plus 13 secant of 3x. And let's say that's equal to 0. All right, and let's say we want to find the solutions from negative pi to 2 pi. There's a 2. All right, now, first thing you notice probably is that it has a squared. And I told you all at the beginning when we were doing quadratics in college algebra that you will never, ever, ever be free of quadratics and factoring. So we're actually going to apply our favorite F word here. And we're going to factor this equation out. Okay, now if we look at the equation closely, we notice that each term in this equation has secant of 3x. Since we have a common term, we can go ahead and factor that out first. All right, so we're going to have secant of 3x, and we're going to take it out from the first term. Right, from this 5 secant squared 3x, we're left with 5 secant of 3x, right? We took out one of these secants of 3x, and we're still left with 1. It's like if we have 5x squared plus 13x, we factor out an x, and we're left with 5x, right? Plus 13, we didn't factor that out, plus 13, but we did factor out the secant 3x, so that secant 3x is no longer there, and this is still equal to 0, okay? Now, just like with quadratics, once we factor everything out, we can go ahead and set each factor to 0. So the first one is going to be secant of 3x equal to 0. And the next one is going to be 5 secant of 3x plus 13 equal to 0. Now, really quick, for the first equation, for the secant of 3x equal to 0, we have to keep in mind the following thing. All right, we know, or we should know, that isn't a horrible thought bubble. Okay, we should know that secant is not defined everywhere in terms of its range, right? Because we want an input, an x value, such that we get an output of 0. Now, if you remember correctly from the previous assignment, the range of secant is going to be from negative infinity to negative 1, or from 1 to infinity, right? Which means 0 is nowhere in this particular range. So this particular equation, the first one that we get, has no solution. So make sure you keep those range values in mind as you work through your homework. This particular one has no solutions. Now we can just go ahead and jump for the second one. Okay, now just like in the previous video where we were solving a particular equation, you want to make sure that this gets isolated first before we start jumping with the x. All right, now to solve this particular equation, think about it as 5 times the smiley face plus 13. To solve for the smiley face, you first want to get rid of the 13, right? Subtract 13 from both sides. Just algebra. 5 secant of 3x equal to negative 13. All right, and again, we still don't have secant of 3x by itself, so let's go ahead and divide by 5. These cancel out. We get secant of 3x equal to negative 13 over 5. Now, if we think about it, even if we were to apply the reciprocal of secant, which is cosine, and do cosine of 3x is equal to negative 5 over 13, 5 over 13 is still not a unit circle problem. Okay, so since we're not working with a unit circle problem, we're going to go ahead and use the calculator to solve 4x. All right, so let's go ahead and I'm going to go ahead and write it over here. Still following the same thing. We have secant of 3x is equal to negative 13 over 5. Okay, so to isolate the x, we need to first get rid of secant. Now, we don't divide by secant. Okay, we have to apply its inverse, which is inverse secant. Right, so secant inverse, remember that negative 1 tells you it's an inverse, times secant of 3x. What you do to one side, you do to both sides. So we go ahead and take the inverse of secant of negative 13 over 5. Now, just keep in mind, you're talking about a negative value. Okay, if you remember from a previous lecture, we know secant is going to be negative in certain quadrants. Okay, they're all positive in quadrant 1. Okay, keep in mind they're all positive in quadrant 1. In quadrant 2, you have that sign, okay, and its reciprocal, which is cosecant, are positive. In quadrant 3, you have tangent and cotangent that are positive. Okay, and in quadrant 4, you have cosine and secant that are positive. All right, so since here secant is negative, okay, we had that secant of 3x is going to be a negative value. We have that we're working with. Okay, so this is going to be secant is negative, right, in quadrant 2 and quadrant 3. So we're actually going to be working with values in quadrant 2 and quadrant 3. All right, so let's go ahead and keep solving. Okay, we know that these cancel out, and we're left with 3x that we want. And 3x is equal to secant, or inverse secant of negative 13 over 5. Okay, negative 13 over 5. Now, we can go ahead and use the calculator to go ahead and figure out what this is, and we'll do that shortly. Okay, but first let's actually go ahead and solve for x. To solve for x, we're going to go ahead and just divide by 3. So we have that our first solution, because remember we're going to have 1, is equal to, and let's go ahead and type this into our calculator. All right, so on our calculator, remember, go to a calculator page and make sure that yours says radians. Mine says degrees. So in case yours says degrees, just go to settings really quick, document settings, change this to radian, and make sure you click make default, otherwise it won't do it. Then you can go back to your current document. All right, so let's go ahead and type in what we had. We had a fraction, right? In the numerator, we had the inverse of secant. Okay, we had inverse secant of negative 13 over 5. Okay, negative 13 over 5. Okay, and this was going to be divided by, this is going to be divided by 3. All right, so control enter to find the actual answer. Okay, and we get negative, I mean not negative, I'm sorry, 0.655196. Okay, so let's go ahead and write that down. We get that x1 is equal to 0.655196. Okay, and remember general solution plus 2k pi, since we're talking about secant. Okay, plus 2k pi, and remember 2k pi was also divided by 3. Okay, because you had to divide the entire thing by 3. Let me backtrack a little bit. Okay, so to not confuse you. Okay, so this is what we had originally, right? 3x is equal to secant, or inverse secant of negative 13 over 5. Okay, now this secant of an inverse secant of negative 13 over 5, and let's go ahead and find the value. Okay, oops. This is inverse secant of negative 13 over 5. Okay, control enter. This is the actual solution that we got, which was going to be, we have that 3x is equal to 1.96559, right? And then we're going to go ahead and add plus 2k pi, since we're talking general solutions. Okay, plus 2k pi. Then you're going to go ahead and divide everything by 3. These 3's cancel out. Okay, so x1 is equal to, which was the first value that we found, 0.655196 plus 2k pi over 3. Okay, this is how we're going to find the general solution for the first one. Now, for the second one, Okay, for the second one, remember that we have to take our angle, which in this case was going to be 1.96559, and we're going to subtract it from 2 pi. So if we do, okay, 2 pi, and remember pi is over here, oops, 2 pi minus the angle that we got, which was this one. Okay, and click enter, we get 4.3176. So we get 4.3176. Okay, and that's going to be the other angle that we work with. All right, so x2, okay, x2, and it's going to be 3 times x2 is going to equal to 4.3176 plus 2k pi. Okay, we divide both sides by 3. These cancel out. We get that the second solution, general solution, is going to be, and if we take this value and divide it by 3, oops, we get 1.4392 plus 2k pi over 3. All right, now those are our two general solutions. Oops, no, I don't want to erase it. These are our two general solutions. Now, the question itself, okay, or in this example, wanted all solutions from negative pi to 2 pi. Now, if you remember negative pi, it's just going to be negative 3.14 more or less, and 2 pi is going to be 6.28. So I want to find all solutions from negative, or approximately negative 3.14 to 6.28. All right, now we can just go ahead and use the calculator for this, for x, and remember, just like we did in the previous video for the unit circle problems, we're going to choose values of k. And this is much easier because you have the calculator to do it. All right, so let's go ahead and look at the potential solutions for x1. All right, for x1, which is going to be that 0.665. Okay, so this plus 2, and let's say k is negative 2. Okay, I'm going to start with negative 2. Control divide, so 2k, which I'm assuming is negative 2 right now, pi, well, let me actually type in pi over 3. Okay, and this gives me negative 3.53, so this one is going to be a solution. Or not going to be a solution because it does not fall in the range. So when k is equal to negative 2, we don't have an answer. Okay, let's say k is equal to negative 1. Okay, we get negative 1.4392, which is going to be in the range of values that we have. Remember, this is going to be our range. My bad. Our range is going to be from negative pi to 2 pi. So the first solution that we have when k is equal to negative 1, okay, is going to be negative 1.4392. So we're going to write that down, negative 1.4392. When k is equal to 0, okay, when k is equal to 0, all of this is 0, so the answer that we got, that 0.655196, is going to be a solution as well. Okay, 0.655196, so 0.655196. All right, the next one, when k is equal to 1, okay, so all we're going to do is just copy and paste. When k is equal to 1, I'm just going to erase that negative. We have 2.74959, which is also a solution. Okay, so let me go ahead and write that down. 2.74959. 2.74959. All right, and then we're going to keep checking until we run out of values within the specified domain. Say the next one is, 2. Okay, we get 4.84. That one's also going to work. Okay, so when k is equal to 2, we get 4.84399. So 4.84399. Okay, and if we check the next possible solution, when k is equal to 3, you get a value that is above 6.28, so that value doesn't count. All right, now we're going to go ahead and do the same thing with the second equation with x2, right? So from x2, okay, we should have 4 solutions as well in this particular case. And again, we're just going to go ahead and take this equation and then substitute k for with integers. So the first one, let me just copy and paste. It was going to be that 1.43, yeah. So plus 2 times, and I'm going to start with negative 2, pi. Remember that negative 2 is the value of k over 3. Okay, and we get negative 2.74, which does fall within the range. So I'm just going to write the answers since you guys know that I'm substituting values of k. So the first solution is going to be negative 2.4, no, 2.74, my bad. 74959. Okay, the next one, let's go ahead and choose negative 1 as your case. We'll just go ahead and change that to 1. Okay, we get negative 0.655196, which is also going to be a solution. Negative 0.655196. Okay, the next value of k, 0, 0, which is just going to be the initial solution that we had, which is 1.4392. Okay, and then you have 1. Okay, 3.53359, which also works. It's going to be 3.53359. All right, and then if you check when k is equal to 2, you also get a solution. Okay, so it's going to be, yeah, it's going to be 5.62799. All right, and then that should be the last one. Yeah, because that value is outside of the range. All right, so those are going to be all the solutions, and I just listed them here. This is for when k was equal to negative 2, when k was equal to negative 1, k was equal to 0, k was equal to 1, and k was equal to 2. All right, now, just a quick note on the word problems in your homework. Okay, the word problems in your homework are actually very, very straightforward. Okay, it's basic algebra, which is why I don't want to go into it. Okay, because I know you guys can solve them. These are calculator problems. Okay, so all you have to do is essentially type in these equations into the calculator and change the values of t. Okay, if you do have any questions, please go ahead and message me through Remind, and I'll be more than happy to help you with those. All right, and make sure you know how to substitute values. So, for example, in question, I believe P, okay, where you're talking about the horizontal distance for projectile. Okay, make sure you know how to substitute for initial velocity, substitute for theta, and know which value of gravity you're going to need. Okay, just a quick hint. There is 2 solutions, and you are going to be using these particular formulas in order to find the other solution. Okay, so make sure that you're paying very, very close attention. All right.